Yeah, let us check now how to execute an OR gate program, which is written using data flow modeling. So let us create a new project over here and select next. And here I select a new directory that's called R underscore 2. And also I name the project as R underscore 2. And next, click next. Confirm it to create. Then I can create an empty project. And here I skip it. Then here I select the max 10 device. As I tend to tell the max 10 device family, the device is already selected here. Then I can have select a next. Then we also click next and finish it over here. So as a finish, file will be opening here. So here we can select a new and you can select a Verilog HDL file, then click OK. Then we just write a comment line here, Verilog code for 2 input OR gate. So R underscore 2, I just write it. Then I write my module R underscore 2. R underscore is the module name. And here I give the output, output is Z, comma, input, I give it as A and B. Then here I just write a statement. It's a data flow modeling, right? So I can, if you want, I can write it here, a comment line. It's a data flow modeling. Then we can see that can use a keyword called assign. So using the keyword assign, we can assign the operation of on the inputs to the output. So A, it's an OR gate, so it is uh, represented as a bar, that is A bar B. Then you can terminate it with a semicolon and end module. So as we enter the module, the program is completed, then save the file with this extension verilog. Then you can expand this analysis synthesis and double click on analysis and elaboration. So the file is getting analyzed and elaborated. It's analyzed for the syntax errors and it gets elaborated for the ports and other details as well. So now we got it here. So let us check now whether we getting the OR operation. So how do we do? Go to run, then run simulation and RTL simulation. Then you can select Verilog. Once again you do it. Run simulation and RTL simulation. So now the model sim will open here. So as usual, the model sim is opened here. This is for R underscore 2. So as it opened for R underscore 2, that's for the previous one, I'm closing it. Yeah, R underscore 2. Then what we can do here is we can expand this library. In the library under the work, we have R underscore 2. Then simulate it. As you simulate it, then you'll be able to get the details of the objects. So select all and add it to the wave. So as you add it to the wave, you'll be able to see the wave uh, signals added to the wave. So what we'll do, we will restart here once again and I set here clock to 100 and first stage I want to be falling and similarly the output to this also I'll set it um, to 25 here, then again this also I'll set it to falling. Click OK. So I ensure that Z is not set up. So now if I run, I'll be able to see that 0 0 it is 0, then 0 1 1, 0 0 0, 0 1 1, 1 0 1, 1 1 1. So almost all the possible combination we're able to check it here. So next what we do, we either close the model sim or you can come back to the quarters And here we are going to check whether we got how our code has been translated. So you can check it out. Our code has been translated as a what? An OR gate. OR gate. So OR gate is having by default it has taken one name for this OR gate, that is Z. So it is taking two inputs AB and given one output Z over here. Okay. So that's how it's getting translated. Even for this also we can add a delay. Even for OR gate also this also we can add a delay. So just by specifying the time delay for the assigned statement also. So we can set the time delay for the assigned statement by using the hash symbol as we have done it earlier. Here also we can set the time delay. Okay. So we can set the time delay. Now let us check how to add a delay to this program. So as you add a delay after this assign, you can give a hash 20 or 25, whatever you want to delay you want to give, you can give it here. As we modify this file, we have to save it once again and run the analysis and evaluation that will check is there any error. So if there is any error, we have to correct the error before we proceed. Otherwise, we can proceed with our subsequent operations. So here I have the model sim open. I'll close the model sim because so that we can run it one more time. So once this is done, now we'll go for running the simulation. So as we run the simulation here, we can see that model sim is open. Then we can uh, select the library and expand this work. Then right click on R underscore 2, then simulate. Then the signals are added to the objects. Then you can select it. Then you can send it to wave, add wave. Then it will come to the wave here. So as it comes to the wave, you can rearrange your output terms. Again, this for this it is going to be 0. Then we'll be able to see that after 20 picosecond, we are getting the response. Now let us change it to 1 and 0 and check. 1 and 0. So one is 1, other one is 0. What's supposed to be your output? Supposed to be your output immediately, but here what happens uh, after 20 picosecond, you will be able to get our output. Now, if you make 0 0 combination again, then again we will be able to see that there is a delay of there's a delay of 10 and 20 picosecond. So you can see that it's supposed to be at this point, but it's happening after a 20 picosecond delay. And coming back and check how our code is performing in terms of translating into a gates. So we can see the netlist viewer. So the netlist viewer will be able to see that still it is considered to be an OR gate. Okay.